Okay, Askar, can you introduce yourself?
I'm Muhammad Ashkar PH, coming from Cochin, Kerala. I'm pursuing my BTech in Mechanical Engineering from Model Engineering College, Trikakara, which is also in Cochin. I'm currently appearing for my final semester examinations.
Okay.
Till now, I have secured a CGPA of 7.8 with no active backlogs. I have already done a diploma in mechanical engineering from Government Polytechnic College, Chertala, which is also in Kerala,
Okay.
with a CGPA of 9. And my 12th education was completed from Government Higher Secondary School at Appalli, which is also in Cochin, with an overall percentage of 90 and PCM percentage of 87. My 10th education was completed from CCPLM Anglo Indian Higher Secondary School, Perumanur, which is also in Cochin, with an overall percentage of 100. My family consists of my father, Hamid PM, working as a carpenter in Cochin, and my mother, Rasia CK, she's a homemaker. My hobbies include playing football, watching movies, and also sometimes I like to sketch pencil drawings. That's also.
So, how many siblings do you have in your family? You've not mentioned.
No, sir, I have siblings.
Oh, you are the lone one.
Only family.
Okay.
Only son.
Okay. So, doesn't your family have any issue with you joining Merchant Navy?
No, sir, when I talked about my ambition towards to become a marine engineer, so they encouraged me to achieve actually.
Okay. Great. Okay, then um, let's ask about what do you any project that you have pursued during your college time or
Since I
during
have
your
done
diploma
a
time. You
project,
need to mention your any specific contribution that you made to project.
yes, I have done a project in my final year BTech Mechanical Engineering.
Okay.
It was based on a fluid mechanics actually.
Fluid
It is
mechanics.
yes.
Okay.
We created flow. Actually, the project title was fabrication and experimental validation of water tunnel design,
Okay. Can you
which is
explain more
basically
on the project and
okay.
what that project
Which is
did?
the project is based on creation of a flow which is similar to riverine flow and canal flows to run the mini turbines to produce small scale electricity.
Small
So which
scale
was
electricity. Okay.
yes. So we do not focus on the turbine part, but we focus on the generation of flow.
Mm-hmm.
So we created a design which has so accurate that it has no backflows and turbulence. Also the flow separation. So we finalized a design and created a CAD model according to that. And based on the CAD model, we created a flow in virtual CFD ANSYS software, and we get a result of zero point 0.5 meters per second of velocity.
Mm-hmm.
And after that, we fabricated a model, real model of the water tunnel, and experimentally validates the flow velocity, but we could only achieve a velocity of zero point 0.3 meters per second.
Mm-hmm.
It is so
And
we can
how do you and I mean remove those, how do you get that kind of velocity fluid? How do you do
we,
you get that riverine flow?
by the dimensions of the water tunnel design, we finalized a pump, a pump which to circulate the flow within the tunnel. Okay, but the flow which is generated has a turbulence because we created the tunnel with the sheet metals and polycarbonate sheets, so that there will be occurrence of turbulence and backflow, also the flow separation. So we could not generate the flow of zero point 0.5 meters per second as the ANSYS software developed.
Okay, okay, good.
So actually we compare the both computational and experimental results of the flow.
Okay, okay.
That's our project.
So, how much are you aware of the duties that you will have to carry out as a marine engineer on board?
To take care of the precautions to be taken before starting the engine, main engine, as well as the boilers, the pumps, the compressors, all the things we should care. We should take care before starting them. We should know about more about the working of those machines, and that's all I know about more about it.
Okay. So are you familiar with the ship's engine room
I had seen some videos
videos?
in the development,
Okay.
but
So you
not.
are familiar with an industrial plant, right? Because you are a mechanical engineer.
Yes,
So you
done some
have you done
internships.
your this thing? I mean, apprentice from some place?
Yes, yes, I have visited Keltron, tool room section for some in in diploma stage also, and also in technical engineering. And we do internships in some industries like HMT, sorry, HMT, something like
HMT.
that.
I mean,
HMT.
what those industries are basically I mean, making or what they are doing.
Uh, Caltrac, which is the industry which produces parts of the rockets for ISRO.
ISRO. Okay.
ISRO.
Anything else?
HMT
I mean,
produces some.
there is an apprentice certificate required, right, to complete your degree.
Yes,
Three
yes,
months or 6 months of apprentice at some industrial, place.
yes.
So, have you done it from any industrial place in industry?
Yes,
Your
HMT
apprentice?
and Caltrac.
Okay. So what basically was your duty during your apprentice? What were you doing? What did you observe?
We have to analyze the working of those machines, like late machine, and we should do the things to produce the small parts of each component of the rocket. And we do such things in the
Can you
industry.
take me briefly into what your day's job was during apprentice? What do you do? What did you do there?
Actually, they is teaches me about all the working procedures carried out there.
Mhm.
Start from the late works and then grinding, milling, such as
Okay.
things.
Okay. Okay then.
Okay.
What are you for how familiar are you with two-stroke engine? What is a two-stroke engine?
Actually, two-stroke engine develops more power and twice the power than that of a four-stroke engine.
Sure. Okay. Rest.
In two-stroke engines, during compression stroke, we not only achieve the compression but also the process of scavenging.
Mhm.
And during the power stroke, we achieving the power stroke as well as the exhaust. But in case of a four-stroke engine, we are achieving those four engine cycle processes in four different strokes of the piston.
What are the name of those strokes? Can you name them?
Compression, suction, compression, power stroke, and exhaust stroke.
Can you repeat them? Suction,
Suction, compression, power stroke, and exhaust stroke.
exhaust stroke. And in the two-stroke engine,
We achieve these four cycles in two strokes of the piston.
okay.
During power
What are
stroke, we
those two
achieving
names? Name of the two strokes?
compression and power stroke. During compression, we are achieving the process of scavenging, and also during the power stroke, we are achieving the process of exhaust.
Okay. So, what are the difference in the components of four-stroke and two-stroke engines?
Two stroke doesn't have inlet valves. They have inlet ports.
Mhm. Anything else?
Um, that's all I know about.
Okay.
And also flywheels.
Flywheel.
Flywheel. Yes. As
Flywheel or
two stroke
flyweight?
engine, flywheel. Two
Flywheel.
stroke engine needs a lighter flywheel compared to four stroke engine because it develops more uniform power during the cycles.
Okay. Ashkar. Next question to you would be What is a freshwater generator?
which is basically working on the vacuum. Sorry, the eventually effect in ships. The creation of partial vacuum creates the water to boil under low pressure, which creates the seawater to evaporate, and then it is condensed to form fresh water. So we use Venturi effect in the ships to produce fresh water.
What equation is that, which is based on which this principle of evaporation, the freshwater generation is based on? Any very famous principle it is?
Venturi effect.
Venturi is the effect, and what is the principle called?
Bernoulli's.
Bernoulli's principle. Okay, so this one you have answered well. Okay.
Thank you, sir.
Oscar, next question will be, what is a pump and what are the types of pumps?
Pump is a mechanical device which creates a liquid movement, and the resistance faced by it produces a pressure which is then converted to potential energy. So there are two types of pumps: rotordynamic pumps and positive displacement pumps. Rotordynamic pumps. Pumps are those mechanical types. Okay.
Yeah.
Okay. Rotordynamic pumps and positive displacement pumps.
Okay, rotodynamic and positive displacement. Okay, can you give me examples of rotodynamic and positive displacement?
Rotordynamic pumps are those having the rotating structures like impeller, propeller, etc. Centrifugal pump is an example for that.
Okay.
Positive displacement pump which forces the liquid in a fixed volumes in each cycles. They are reciprocating pumps, piston and cylinder pumps.
Right. Okay. Any more types of pumps that you are aware of?
Gear pumps, low pumps, screw pumps. They are also positive displacement pumps.
Okay. Now coming to air compressor.
Okay, sir.
Okay. What does an air compressor do?
Actually, it pressurizes the air by reducing the volume of air.
And how does it do it? How does an air compressor work?
By the electric motor drive, the piston cylinder arrangements compresses the air to pressurize, and it is then stored to the air bottom.
Okay. Okay. Are you aware of a refrigeration cycle?
Yes, sir.
How does a refrigeration plant or a refrigeration cycle look like or work? Can you explain?
It has basically four components: a compressor, a condenser, a thermostatic expansion valve, and an evaporator. We achieve the low temperature in the evaporator.
Okay.
First of all, the compressor pressurizes the vapor refrigerant to a high temperature and a high pressure refrigerant, and this then pass to the condenser, which condenses the evaporator to a liquid form. So the liquid refrigerant, which is having low temperature but high pressure, which is passed through a thermostatic expansion valve, which is then supplied to the evaporator, which is coming to contact with the air at the evaporator space, cools down the air by absorbing the heat from the evaporator.
What does an evaporator? I mean, how does thermostatic expansion valve has to open up, right?
Yes.
Pass on the refrigerant liquid.
Okay.
I mean, how does it know that The amount of opening, which what decides the amount of opening of a thermostatic expansion valve?
So near to the evaporator, there will be a sensing bulb which senses the
Great,
temperature of
good
the.
answer. Okay, I got my answer.
Yes, sir.
Okay, so you are aware of the process.
Capillary action. Right,
Okay,
sir?
right, right, right. Okay, now tell me, have you been to your workshop?
Uh,
Workshop.
but, yes, sir.
What does a lathe
First
machine
year
do?
we have workshop sessions.
What does it do? What does a lathe machine do?
The, so actually just machining the components.
Mhm. And how does it,
Uh,
have you worked on
then,
lathe machine? How does it work?
it rotates the workpiece, and when we feed when the tool is put into the work, the material is removed from the workpiece.
Mhm. I mean, what all other, I mean, have you used any lathe machine?
Yes, sir.
And how do you use it? I mean, you have been given a job piece and it has to be fabricated into some shape or size. How do you work on that job piece on a lathe machine?
Uh, so
Like
we
you have been
actually
given a
we
cylindrical shape and then you have to convert it into a, I mean, square or a rectangular surface, cuboid. How do you make it that way?
sir, we fix the I fix the job in the spindle, sorry, the jack,
Yes,
cylinder, sorry, and the okay, check of the lathe,
right,
and
right,
then we
right.
feed the
Okay, okay. Then
when
what
we
do you
feed the
do?
tool only. Then we feed the tool. Then we
Tool, yes, you are aware of it. Yes, that is the process. Yes. Then you
the
rotate
tool
the
is fed
chuck and then you
by
insert
the
the
check,
tool.
and
Yeah.
the tool
And
is
you
fed
cut
into
it
the work.
accordingly. Yes. Yeah. That's the press. I mean, through a precision tool, you will be cutting it according to your requirement. You right.
Yes.
So that is the purpose of a lathe machine. Okay.
Okay.
Okay. Now, can you tell me what is a destructive and a non-destructive test?
Destructive test means which destructs the material. Test the material you say by destructing it, but non-destructive testing, it will not cause any defect to the material which we are going to test.
So, can you name the any one or two of destructive tests and non-destructive tests? How they
Tensile
are done?
stress, tensile stress and bending stress. Then harness test, like Vickers harness, linear harness.
Okay.
They are all destructive tests which destroys the specimen. But in case of non-destructive tests, there are some visual examinations with microscope and also lens and dye penetration test, and also the magnetic particle inspection. It's also come under the non-destructive test.
Okay. So, can you tell me the process of any? I mean, either magnetic particle separation test or this one dye penetrant test.
So magnetic particle penetration test, which is we prepare the surface of the. This is actually to find the defects, surface defects or subsurface defects of the material.
Right.
So firstly, we prepare the surface of the material to be tested, and we pour the magnetic particles or the metallic particles on the surface, and we apply the magnetic field into the substance, and also then so when we apply the magnetic field, the magnetic particles will accumulate at the cracks of the material, which we can analyze. If there is a crack, there is an accumulation of magnetic particles at that point. And after we remove the magnetic field, remove the magnetic particles, we can analyze whether there is a crack, subsurface crack or surface crack.
Okay, good, good. Are you aware of what a boiler does on board ship?
Boiler basically produces steam from water.
Mhm. And what does a boiler look like? I mean, how many types are there of boiler and how it does so, how it produces steam?
It is sorry, the boilers have heat sources which produces heat or combustion. The exhaust gas or the flow gases from the boiler boils the water and it produces steam. So basically, there are two types of boilers: water tube boilers and smoke tube boilers. Water tube boilers will have water circulating through the tubes, which means the tubes are surrounded by the hot flue gases or exhaust gases. But in case of smoke tube boiler, the smoke or hot flue gases pass through the tubes, which are surrounded by the water. So the water will get converted to
Let me
steam.
ask you one or two questions from electrical. How much is the voltage generated on board ships?
I don't know, sir.
You don't know. Okay. How much is the voltage that comes to your home?
230, I think.
220. Okay. What is the frequency of that?
56, sir.
50. Okay. 50 hertz. Okay. So how is electricity? My question is this, that how is electricity generated on board ship?
Electricity generator, which is I don't know. I'm sure about the answer. It's through alternators
Yes.
by the running of the engine,
Yes.
like the automobiles.
Yes. Right. You're
Sir,
correct. Yes, you're correct. So it's through an auxiliary engine or generators that we call that we
generator
run,
engine.
and it is coupled with an alternator. An alternator is converting that mechanical energy into electrical energy. It is same as the opposite to motor is driving the electrical energy and taking up the electrical energy, converting into mechanical energy, which is used to drive a pump. Similarly, mechanical energy is converted from a generator or some this thing, and then it is converted through an alternator, and then it reaches to the main bus bar. 440 volts. Okay, then we use it as 440, and we use a step down transformer if we require, like lighting arrangements and all, they require 220 volts. So there is a 220 bus bar panel, there is 440 bus bar panel on board, and there is something called high voltage requirement also, for which we have step up transformers. Okay, Askar, I think we are done with your interviews. I've asked a lot of questions from you, and that's a good thing.